Let's start the journey of software testing. Software testing is the process of evaluating a software application to ensure it meets the required quality standards and functions as expected. It's not just about finding bugs, it's about verifying that the product works smoothly, safely, and efficiently for users. Testing plays a crucial role in the software development lifecycle, helping detect issues early, reduce costs, and improve customer satisfaction. It involves different levels, like unit testing for individual components, integration testing for combined modules, and system testing for the entire product. We also use various techniques, like black box testing, where we test the functionality without seeing the code, or white box testing, where we examine the internal logic. In today's fast-paced tech world, testing is evolving beyond manual checks into automation, continuous testing, and quality engineering. Simply put, software testing is the gatekeeper of quality, ensuring that software not only works but works well. Let's explore this exciting field together. Welcome to our presentation. As Aristotle said, quality is not an act, it is a habit. This holds true for software testing too, where we ensure quality by identifying errors and rectifying them. Software testing is the process of validating the functionality of software to ensure it works as intended. It's about checking whether the software behaves the way it should. Testing plays a key role in making sure the software meets all the requirements specified by the client or the end user. By doing this, we make sure it delivers the right features and value. One of the most important goals of testing is to help locate errors and defects. No software is perfect on the first try, so testing helps us catch issues before they reach the user. Ultimately, software testing improves the reliability and performance of the product. A well-tested application runs smoother, crashes less, and provides a better experience. In short, software testing ensures quality, builds trust, and delivers confidence in the final product. Stay tuned as we dive deeper into the world of testing. Moving on to our second slide, Benjamin Franklin once said, "The bitterness of poor quality remains long after the sweetness of low price is forgotten." So, we have various types of software testing to ensure top-notch quality. We start with unit testing, which is usually done by developers. It focuses on testing individual components or functions of the code in isolation to ensure each part works correctly. By catching errors early at the smallest level, developers can prevent bigger issues later. Next, we have integration testing. Once individual units are tested, integration testing checks how these modules work together. It validates the interaction between different parts of the application to ensure they communicate properly. Then comes system testing, where we test the entire software as a complete system. This phase evaluates whether the software meets all specified requirements, covering functionality, performance, security, and more. Finally, we have user acceptance testing, or UAT. In this stage, actual users test the software to confirm it's usable in real-world scenarios and meets their expectations before it goes live. Each testing type builds on the last, working together to ensure the software is reliable, functional, and ready for use. Now, in this presentation, as W. Edwards Deming stated, "In God we trust, all others must bring data." We follow systematic methods of testing to provide reliable data. Let's talk about different software testing approaches. First, we have white box testing. This type of testing examines the internal structure of the program. Testers look at the code and logic to make sure everything works as it should from the inside. Next is black box testing. Here, testers don't look at the code. Instead, they test the software's functionality by giving inputs and checking the outputs without knowing how it works internally, just like an end user would. Then comes grey box testing. This is a mix of both white box and black box testing. Testers have some knowledge of the internal workings, but still focus on testing from an external perspective. Finally, there's non-functional testing. This checks things that aren't about specific features, like performance, security, or how well the software handles stress. Each of these testing types helps ensure the software is reliable, secure, and works smoothly for users. In this presentation, we will see the software testing lifecycle. In the words of Beverly Sills, There are no shortcuts to any place worth going. This is particularly true for the systematic process of software testing. Let's understand the software testing lifecycle, or STLC. This is a structured process that defines different stages testers follow to ensure high-quality software. The first stage is requirement analysis. In this phase, testers study the requirements and gather information to understand what needs to be tested. They identify what's testable and clarify any doubts with stakeholders. Next comes test planning. Here, the team creates a test plan, deciding the scope, objectives, resources, timelines, and testing strategies. They also estimate effort and assign responsibilities. Then we move to test case development. Testers write detailed test cases and prepare test data. These test cases will guide them on what to test, how to test, and what results to expect. The fourth stage is test environment setup. This means preparing the hardware and software conditions needed to execute the tests. Sometimes it's done by a separate team or in collaboration with developers. Next is test execution. Testers run the test cases and compare actual results with expected outcomes. Any differences or failures are reported as defects to the development team. Finally, we have test cycle closure. Once testing is complete, the team evaluates what was done, documents lessons learned, and shares a final test report. This helps improve future testing projects. Each stage in the STLC builds on the previous one, ensuring a thorough and organized approach to testing. By following this cycle, teams can deliver better, more reliable software. Finally, remember what Henry Ford said: quality means doing it right when no one is looking. Software testing is critical for delivering a high-quality product that meets customer expectations. Software testing plays a critical role in delivering high-quality products. It helps identify bugs and defects early, so they can be fixed before the software reaches users. This saves time, money, and effort in the long run. Testing also ensures that the software meets all functional and business requirements. It checks whether the application behaves the way it's supposed to, under different conditions and scenarios. Another key benefit is improving reliability and user trust. Well-tested software is more stable, secure, and performs better, which leads to higher customer satisfaction. Finally, software testing reduces risks. By uncovering issues related to performance, security, or usability before release, testing prevents costly failures or damage to a company's reputation. In short, software testing is not just about finding bugs, it's about delivering quality, building confidence, and ensuring success. Thank you for watching the first chapter of our software testing introduction. We hope you found it helpful and informative. If you'd like a copy of the transcript, feel free to reach out to us via email or WhatsApp. We'd be happy to share it with you. Don't forget to subscribe to our channel to stay updated with more content and upcoming chapters. We also invite you to join our official WhatsApp group for regular updates, free sessions, and opportunities to clarify any doubts you may have. It's a great space to connect, learn, and grow together. Click here to join the WhatsApp group mentioned in the comments.